Note 6.5c, complex numbers. Recall that the square root of -1 is I, and the sum of squares formula is a squared plus b squared equals a minus bi times a plus bi. I to the 0 power is 1, I to the first power is I to the second power is -1, I to the third power is I to the fourth power is 1, and the cycle continues indefinitely. To find the position of the cycle for I to the nth power, divide n by 4, and the remainder, 0, 1, 2, or 3, will be the position in the cycle. Example 1. Identify each number graphed and find the magnitude, the distance from the origin. So this number right here looks like we have 1, and then 1, 2, 3, 4, 5. 5. So we have 1 real and 5 imaginaries. So 1 plus 5i would be the complex number. You could think of the reals as x and the imaginaries as y. The magnitude would be the absolute value of 1 plus 5i. That will equal the square root of 1 squared plus 5 squared. And that is the square root of 26. The square root of 26 doesn't reduce, so we're done. For the next one, it looks like we have 5 and then 1, 2, 3, -3. So we have 5 real and then -3 imaginary. So our complex number would be 5 minus 3i. The absolute value of 5 minus 3i would be the square root of 5 squared plus 3 squared. Square root of 34. So our magnitude is the square root of 34. That's the distance from this point to the origin. Example 2. Graph each number of the complex plane and find the magnitude, distance from the origin. Okay, we have a complex number of -3 minus 5i. So we're going to go 1, 2, 3 to the left and then down 5. 1, 2, 3, 4, 5. And then we want to find the distance from the origin. So we have absolute value of -3 minus 5i, and that's going to equal the square root of -3 squared plus -5 squared. So that is the same as before, square root of 34. So the magnitude is the square root of 34. B, the complex number is -2 plus I. So we go back 2 and then up 1 because there's just one I. And then we want to find the distance from the origin, the magnitude, absolute value. So we have absolute value of -2 plus I equals the square root of -2 squared plus 1 squared. So that's the square root of 5. Example 3. Simplify. We have the I to the 72th power. So we're going to divide 72 by 4. We always divide by 4 because our cycle has 4 elements in it. So 4 goes to the 7, 1 time. 4 goes to the 32 8 times. We have a remainder of 0. So that means we have I to the 0th power. That just equals 1. B, I to the 53rd power. Divide 53 by 4. 4 goes to the 5 1 time. 4 goes to the 13 3 times. We have a remainder of 1. So we have I to the 1st power. That's I. C, I to the 18th. Divide 18 by 4. 4 goes to the 18 4 times. 4 times 4 is 16. 18 minus 16 is 2. Your remainder is 2. We're not concerned with the quotient on these. We just care about the remainder. So your answer is I squared, which is negative 1, which is actually a real number. Same thing with A. A is also actually real. It just looks imaginary from the beginning. D, I to the 67th power. So we're going to divide 67 by 4. Four goes to 27 6 times. Your remainder is 3. I to the 3rd power equals negative I. So this is also imaginary. I to the 82 for E. So we're going to divide 82 by 4. So 20 remainder 2. So I squared equals negative 1. This one is real. And then F, I to the 98th power. Divide 98 by 4. Your remainder is 2 as well. So this one's also real. So notice any I that's to an even power is actually a real number. But if the I is to an odd power, it's imaginary. Example 4. Simplify the expression. A, x plus 3i times x minus 3i. This is our sum of squares. These are conjugates. Two conjugates put together, multiplied together, gives you either a sum or a difference of squares, cubes, etc. So x plus 3i, x minus 3i. We want to find the area of all 4 boxes and then add them together. X times x is xx, that's x squared. X times negative 3i is a minus 3xi. X times 3i is plus 3xi. And then negative 3i times positive 3i is negative 9i squared. So then we have x squared minus 3xi plus 3xi minus 9i squared. Now I squared is negative 1. And these two numbers cancel. So we have x squared minus 9 times negative 1. So we have x squared plus 9. That is our simplified expression. B, x minus 6i times x plus 6i. Draw our box. Write one of the binomials on the side and one of the binomials at the top. Find the area of each of the boxes. And we have really a negative 1 there. And those cancel. So we have x squared plus 36. C, 5i times 6 minus 7i minus 4, parentheses 6 minus 10i. Multiply those 5i's into each term to get 30i minus 35i squared. Multiply negative 4 to each term. Negative 24 plus 40i. Remember, I squared is really a real number, so you're going to have 30i minus 35 times negative 1 minus 24 plus 40i. Let's group together the like terms. So we have 35 minus 24, and then 30i plus 40i. So we have 11 plus 70i. That's your simplified expression. Your answers for all of these simplified expressions with the real and imaginary should only have 2 terms at the end at most. D. Negative 8i times 2 plus 9i plus 5 times 4 plus 9i. So let's distribute the negative 8i into each term. So we have negative 16i minus 72i squared. And then we'll distribute the 5 into each of these other terms. So we have plus 20 plus 45i. Remember, I squared is really negative 1. So then we have negative 72 times negative 1 plus 20 minus 16i plus 45i. So we have 72 plus 20 minus 16i plus 45i. Combine the like terms. 92 plus 29i. And that would be your simplified expression. E, 8 over 6 plus 9i. We want to rationalize this denominator. To do that, we're going to multiply each numerator and denominator by the conjugate, the complex conjugate of the denominator. Remember, 2 conjugates together makes a sum of squares or a difference of squares. So we're going to multiply 8 by each of those. 8 times 6 is 48. 8 times negative 9i is a minus 72i. So again, recall that equation. A squared plus b squared equals a plus bi times a minus bi. So we'll have 6 squared plus 9 squared. So that'd be 6 squared plus 9 squared. So we have 36 plus 81. So our simplified expression be 48 minus 72i all over 117. But you could simplify this even more. You could divide everything by 3. (16 minus 24i all over 39). And this would be your simplified expression. F, 9 over 7 minus 3i. Multiplied by the conjugate, 7 plus 3i. So then you have 63 plus 27i all over 7 squared plus 3 squared. So then we have 63 plus 27i all over 49 plus 9. So 63 plus 27i all over 58. Example 5. Solve by taking square roots. A. 4p squared plus 3 equals 0. The first thing you want to do is isolate the squared part. So we have 4p squared equals negative 3. To isolate it further, we're going to divide each side by 4. P squared equals negative 3 over 4. Square root each side. So we have p equals plus or minus the square root of negative 3 over the square root of 4. So p would equal plus or minus I square root 3 all over 2. B. 2n squared plus 10 equals 0. Subtract 10 from each side. 2n squared equals negative 10. Divide by 2 each side. N squared equals negative 5. Take the square root of each side. Put a plus or minus, and then we have n equals plus or minus I times the square root of 5. And that's our solutions. Example 6. Solve using the quadratic formula. Recall from before that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A. 7x squared minus 5x plus 2 equals 0. The first step we want to make sure is that this right side of the equation is 0, so that works. After that, identify a, b, and c, just like when you were factoring. And then plug into the quadratic formula. And all over 2 times 7. Make sure you put parentheses around here. For example, if you were using a calculator and you didn't put parentheses around this negative 5, it would give you the wrong solution. So let's simplify this up. 5 plus or minus the square root of 25 minus 7 times 2 is 14. 14 times 4 is 56. All over 14. So we have 5 plus or minus the square root of negative 31 all over 14. Negative side of the square root gives you an I. So your solutions are x equals 5 plus or minus I square root 31 all over 14. There's no numbers we can factor out to reduce the fraction, so we're done. B. 3x squared plus x plus 5 equals 0. There's a 0 on the right side of the equation, so we're good with that one. Identify A, B, and C, and plug into the formula. A is 3, B is 1, C is 5. So for B, we're going to put 1. For A, we're going to put 3. And then for C, we're going to put 5. Let's reduce this a little bit. So we have negative 1 plus or minus the square root of 1 minus 5 times 3 is 15. 15 times 4 is 60. All over 6. 1 minus 60 is negative 59. And if you have a negative side the square root, you change it to an I. So we have x equals negative 1 plus or minus I times the square root of 59 all over 6. The square root of 59 can't be reduced any further, and there's nothing you can factor out to simplify the fraction. So we're done.